Okay, so let's say we have an AC power source, an amplifier connected to ground. And then we connect a load, a resistor, which in this case will be a speaker, and its resistance or impedance will be 2 ohms. And now the amplifier will try to push current through the resistance to make it do work. By increasing its output to 1 volt, it will push the current through the speaker, the circuit will close through ground. And now the power equation is V times I, which means you multiply voltage by current. The more voltage, the more current, the more power you get. But we don't have I anywhere here. So we'll use Ohm's law, which gives us current as voltage over resistance. As voltage increases, more current is being pushed through the load. So I increases. As resistance increases, this load, this resistor, slows current flow down. So now we plug this I here, and we get V times V over R, resulting in V squared over R. So let's plug in the numbers. We have V1, which is 1 volt, and for this we calculate P1, which is 1 volt squared over the resistance of 2 ohms. And this results in 0.5 watt, half a watt. If at the amplifier's output the voltage would increase to 2 volts, so it would double, for this V2 we would have, for 2 volts we would have power P2, 2 volts squared over R of 2 ohms, resulting in 2 watts of power. So we can see that for doubling of voltage, we quadrupled the power. And the reason why this doubling of voltage increase resulted in quadrupling the increase in power is because the voltage is squared in the power equation we got. So we have a power ratio of 4:1. Half a watt became 2 watts, which was the result of voltage rising from 1 volt to 2 volts, meaning voltage ratio is 2:1. So let's start with the basic equation we use for power, for comparing powers. 10 base logarithms comparing the two powers, P2 to P1, so 10 logarithms out of 4:1 ratio, which is 6 dB. And by the way, 3 dB is doubling of power if you plug it into that equation 2:1, which means that 2 steps of doubling of power, 3 dB plus 3 dB, resulted in quadrupling of power, same as 2 times 2 equals 4. So now let's start off the same equation, 10 logarithms, and we have P2 to P1 again, still comparing powers here, not voltages. And let's substitute the powers, express it with power equation with voltage squared. So what we get is, continuing the equation here, we have V2 squared over R, the speaker load, speaker resistance, V1 squared over R, the same speaker resistance. So these two resistances or impedances, doesn't matter in this example, cancel each other out. So we're left with 10 logarithms of V2 squared over V1 squared. And we can take these two squares, put them here, and by properties of logarithms, it can go to the front, becoming 2 times 10, and hence the equation for comparing voltages, as we did here, V2 to V1, is 20 logarithms of V2 to V1, the equation we use for comparing voltages it stems from the equation for power with the 10 in front and is a result of the squared voltage in the power equation we got. So it's 20 logarithms of doubling of voltage 2/1, which is 6 dB. So as we can see, the same gain of 6 dB causes doubling of voltage, but quadrupling of power thanks to the squared voltage in the power equation.